Hey guys, this is Eddie the Magic Monk. One of my students asked me to do this question with them recently, and it's extremely difficult. So, if you're trying this out and you're finding that you're not getting it straight away, don't worry, you're not the only one. If you're asked to do this problem at an age of, I don't know, 15, 16, it is a pretty difficult problem. So have a go at it, and I'm gonna work through it in a second. So if you want to watch me do that, then stay tuned. So I like to draw a picture of everything whenever I work through a problem, and you can see that basically the problem is a gas molecule. Oops. Is moving with a speed of 300 meters per second. Okay, and it collides elastically with another molecule of the same mass, which is initially at rest. So it doesn't say what direction it's moving at, so I'm just going to assume that it's moving along the x direction, right? Because it doesn't specify, so you could theoretically say that you want to move it at any direction you want, but I'm just going to make it move along the x so we can do all the calculations a little bit easier. So I have the first molecule, which I'm going to call M1, right, mass 1, because I don't know the mass of it. And then it moves to the right at a speed of 300 meters per second, and it collides with mass 2, which is not moving. Okay, now this is before the collision, so I'm going to put before. Alright, now what happens after the collision? After the collision, might use a different color, change it up. After the collision, what happened is the first molecule, which is M1, molecule 1, or mass, actually M1 actually refers to the mass of it, is now moving at an angle of 30 degrees to its initial direction. So initially it's moving along in this direction, right? So I'm just gonna put a dotted line representing the initial direction. Okay, now M1 is now moving 30 degrees along the initial direction, 30 degrees from the initial direction, and this is where M1 is. Okay, and then we have our second molecule, which is obviously moving at some other direction. We have no idea. And I'm just going to say it's moving at theta. Okay, I have no idea what theta is, but I know that M2, so M1 collides into M2, M1 then flies off in a direction of 30 degrees from its initial direction, and then M2, we have no idea what direction it's going to move at, but let's say the initial direction is 0 degrees. Okay, theta is what we're trying to find. Actually, we're trying to find theta, which is the angle, okay, the angle that mass 2 is moving, or molecule 2 is moving, and we also want to know the speed of each molecule after the collision. So we want to know what speed M1 is moving at and M2 is moving at. So M1 originally is moving at 300 meters per second, And now it's moving at some unknown speed I'm going to call v1. Okay, the number 1 represents the first molecule, the speed of the first molecule. And the second molecule, the target molecule, okay, is moving at a speed of v2. Alright, no idea how fast it is. Okay, and obviously we need to find the speed. Okay, so we need to find the magnitude of it. So actually I'm just going to put 2 vertical bars around it to represent that I'm looking for the magnitude of the speeds. Okay, so let us now try and figure all of this out using the equations that we know. So what do we know about the equations? Well, we know that the momentum is conserved. So momentum before equals momentum after, right? Because of what it said in the above paragraph, that momentum is conserved in such a collision. So momentum before is momentum after. Now what is momentum? Momentum is mass times velocity. So m1 v1, so the mass, we don't know what it is, so I'm just going to write m1 times the velocity. Actually, let me write the equation first. m1 v1 is equal to, actually m1 v1 plus m2 v2 is equal to momentum after, which is m1 v1 plus m2 v2. Alright, the mass of the object times the velocity of the object, of the first object, plus the mass of the second object times the velocity of the second object equals the same thing, right? Momentum before equals momentum after. Question is, what is the speed after? That's what we're trying to find. Okay, so in 2v2 we know is 0 because v2 is 0. Mass 2 is not moving. Okay, it says in the question that the molecule with another molecule of the same mass, which is initially at rest. So m2 is not moving at all, so m2 has a velocity of 0. So m2 times 0, we can just cross this out completely. So we can just substitute in m1 times 300 equals m1 v1. We don't know what v1 is. And m2 v2, we don't know what v2 is. Okay, now unfortunately we now need to take into account the direction of all the velocities. Okay, because the velocity right now, v1, is moving to the right, whereas v1 on the right hand side for the mass 1, it's moving at this direction, and mass 2 is moving at this direction. So we need to split this up into vertical and horizontal components. So I'm going to have now another 2 equations. I'm going to have, actually this equation isn't even right technically because we haven't split it up into vertical and horizontal components. So I'm going to now have vertical momentum and horizontal momentum. Now let's do the vertical momentum first. Now you can see here on the left hand side, before beforehand, before the collision, there is no vertical momentum, right? Neither of these objects are moving up and down. So vertical momentum will be zero because they're not moving upwards or downwards. Velocity is zero for the vertical direction. Now afterwards, M1 is moving vertically at a speed of whatever the length of this arrow is, right? And because we have a right angle triangle here, the vertical component of the velocity will be v1 times sine 30. So that is the vertical component of the speed going up. So I have m1 times v1 sine 30. Right, that's the vertical momentum. Plus m2 is moving in this direction, so the vertical component is then again m2 times v2 sine theta. Now notice how we don't really know whether this object is going to move downwards, right? I'm just hypothetically assuming that theta is going to be the negative number. But if it's not, if it gives us theta as a positive number, that means this object is moving upwards in the same way as m1, but we don't know for sure. But anyway, the vertical component of the speed is v2 times sine theta. Okay, so now we need to look at the horizontal momentum. So that's the equation for the vertical momentum. Then we're going to look at the horizontal momentum. We're going to come back to the vertical momentum equation in a second. So the horizontal momentum, well, the mass is moving to the right. Okay, so the mass is moving to the right at a speed of 300, so it's 300 times m1, or m1 times 300. Alright, it's moving to the right. The right hand side is positive. So m1 is also moving to the right here, and this direction is going to be, let me just use another color so we're not confused. This direction is going to be, let me draw another arrow pointing to it. This arrow is going to have a magnitude of v1 times cos 30, right? Because it's moving to the right hand side, and the angle here is 30 degrees. I've now covered it up with the arrow, unfortunately, but the angle is 30 degrees. So the horizontal component of the velocity is v1 cos 30. Right, so it's going to be m1 times v1 cos 30, right, because momentum is mass times velocity, plus m2 times v2 cos theta, right, because the horizontal component of the second molecule, right, this is the velocity of it, so cos theta will be the horizontal component of this speed, this velocity vector. Okay, so there is my two equations for vertical and horizontal momentum. Now, one important piece of information is that it says that a gas molecule, okay, is colliding with another molecule of the same mass. Same mass. So what does that mean? That means that M1 is equal to M2. Alright, so I'm going to write that in big letters. M1 is equal to M2. So therefore, instead of separating them, I'm just going to say they're M. Okay, so therefore, I don't need to say M1 or M2 anymore. So I'm going to rub out the 1 and the 2. It's all the same. So therefore, what I'm going to do now is I'm going to divide every single term by M to simplify the equations. So I'm going to divide this whole thing by M. I'm going to divide this by M. I'm going to divide this by M. So then I will get 0 equals V1 sine theta plus V2 sine theta. V1 sine 30 plus V2 sine 30. If I rearrange this even more, I will get V2 sine theta is equal to negative V1 sine 30. Right, because I'm moving this term to the left hand side. Now, if you have a look at V2 sine theta, what this is saying is the vertical component of the speed of my second molecule. So I've now got an expression for V2 sine theta in terms of V1. Right, it's going to be equal to negative V1 sine 30. So whatever V1 is, once I find that, negative V1 sine 30 will give me V2 sine theta. Okay, now let's continue with the horizontal momentum. So I'm going to now do a similar thing and simplify this second equation. I'm going to divide everything by M. So then it's equal to 300 equals V1 cos 30 plus V2 cos theta. Okay, and then I'm going to also rearrange this to give me an expression for V2 cos theta. So I will get V2 cos theta equals 300 minus V1 cos 30. So now I have an expression for the horizontal component of V2. So you can see here I now have a lot of equations and quite a few unknown variables. I have one equation, so I'm going to call this equation 1. I'm going to call this equation 2. Right, how many unknowns do I have? Well, I don't know V1 or V2 or theta. I have two equations but 3 unknown variables. So that's not enough. If you have 3 unknown variables, usually you would need 3 equations to solve it. So where's my third equation coming from? Well, it's going to come from the original information where it says that the kinetic energy of an object of mass m kg is moving at Vms is 0.5 mv squared. So my kinetic energy equations is going to be half mv squared before is equal to half mv squared after. Now notice how initially I had 2 objects. So it's going to be half of m1v squared plus half of m2v squared equals half of m1v squared plus half of m2v squared. Alright. So well, initially because v2 is 0, actually we've got to put v1 and v2 as well. Okay, so initially v2 is 0 because initially m2 is not moving. Alright, so I'm gonna substitute 0 into v2. v2 is 0, so I can cross this out. So therefore I have half m1 v2 equals half m1 v1 squared plus half m2 v2 squared. Now, kinetic energy is a scalar quantity. So because it's not a vector quantity, we don't have to do vertical or horizontal components. It's just the magnitude of each of these vectors, the magnitude of the vectors for the speed, right? Whereas when we're dealing with momentum, we had to separate it into vertical and horizontal components because velocity is a vector quantity, momentum is a vector quantity, whereas kinetic energy, the v refers to speed, which is a scalar quantity. Alright, so beforehand, the kinetic energy is half times m times v is 300 squared. And afterwards we have half times m1, which is just m times v1 squared, plus half times m times v2 squared. Right, we don't have to do the cosine or sine anymore. We just want the magnitude of each of these speeds. Okay, so if we continue with this, notice how every term has a half. So if I multiply the whole thing by 2, I can get rid of all the halves, so it's just 300 squared m equals m times v1 squared plus m times v2 squared. And if I can now get rid of all the m's because I can divide every term by m. Let me just use a different color again. I'm going to divide everything by m. So then I can, actually this is probably clearer, times by 1 over m. So if I expand that out, I will get 300 squared. Let's just put 300 times 300. That is 9 with 4 zeros. 90,000. Alright, equals v1 squared plus v2 squared. Okay, so now I have equation 3, which is really helpful because we have 3 equations and 3 unknowns now. Alright, now I'm going to write the 3 equations together so we can see, we can get a better idea on how we can solve them. So these are my 3 equations. I have equation 1, equation 2, and equation 3. Alright, and 3 unknowns, v1, v2, and theta. Now, just to make these equations a bit easier to represent, I now want to bring in some simple trigonometric identities. Okay, and that is sine 30 is just equal to a half. Okay, and cos 30 is equal to square root of 3 over 2. Right, if you have a calculator, you can probably just type them in and it'll tell you that. So I can replace that with this sine 30 and cos 30, just so it looks a little bit better than having some trig ratios there. So equation 1 is now negative v1 times a half. So negative v1 over 2 equals v2 sine theta. So I'm copying from equation 1. And then equation 2 is now equal to 300 minus v1 times square root of 3 over 2. So square root of 3 over 2 times v1 equals v2 cos theta. Okay, now what I'm going to do is something that's going to help me solve these equations. And that is, I'm going to square both sides of equation 1. Right, I'm going to square both sides of equation 1. And that's going to give me, the new equation 1 is now v2 squared sine square theta. Sine square theta just means sine theta times sine theta. Another way of writing it. Equals v1 squared, okay, the magnitude of v1 over 4. Okay, you're probably wondering why I'm doing that, but you'll see it in a second. Equation 2, if I square both sides, I will get, on the right hand side, actually let's do the left hand side first. So I have 300 minus square root of 3 over 2 v1 times 300 minus square root of 3 over 2 v1 equals v2 squared cos square theta. And now we want to try and expand this out. And if you're okay with binomial expansions, you can do it a little bit quicker, but basically it's going to equal 90,000 and then it's going to equal plus square root of 3 over 2 times square root of 3 over 2 will be 3 over 4 v1 squared, and then in the middle it's going to be minus 2 times 300 times square root of 3 over 2 v1. The 2 times and over 2 will cancel each other out, so it's going to be equal to 90,000 minus 300 times square root of 3 times v1 plus 3 over 4 v1 squared. Now it looks crazy right now, but it's going to be a little bit easier soon. So that's my new equation 2. And what I'm going to do now is I'm going to use the method of solving simultaneous equations, and I'm going to go equation 1 plus equation 2. So I'm going to plus the left hand side to the left hand side plus left hand side, and right hand side plus right hand side. So left hand side plus left hand side, I will have, oh, why did I say 1 plus 1? equation 1 plus equation 2. So it's going to be v1 squared over 4 plus 90,000 minus 300 square root of 3 v1 plus 3 over 4 v1 squared equals v2 squared sine square theta plus v2 squared cos square theta. Okay, now how do we simplify this? Well, if we simplify it by going v1 squared over 4 plus 3 over 4 v1 squared over 4, these two terms will simplify to 3 over 4 plus 1 over 4, so that's 4 over 4. So that will just turn into v1 squared. These two terms just simplify to v1 squared. Okay, v1 squared plus, let's do the second term first, minus 300 square root of 3 v1 plus 90,000. This is looking very similar to a quadratic, equals v2 squared. Now I'm going to factorize v2 squared out, so I will get sine square theta plus cos square theta. Okay, now we love this little expression here because if you remember in Pythagoras theorem, a squared plus b squared equals c squared. Right, now if c is equal to, in a Pythagoras, in a right angle triangle, right, if we have an hypotenuse c, if c is equal to 1, right, a is equal to, let's say theta is here, a is equal to sine theta and b is equal to cos theta times 1. Right, so sine square theta plus cos square theta is equal to 1 squared. So this just equals 1. Right, it's a trigonometric identity. Sine square theta plus cos square theta is equal to 1. So I can now cross this whole thing out, just change it to 1, and then I'm going to move the v1 squared to the left. So I have, what do I have? v1 squared. Oh no, I can't do that. Okay, so that is my new equation. I'm going to call this equation 4. So equation 4 is just this. Okay, that's equation 4. Okay, now I'm going to go back to equation 3, which was formulated from the kinetic energies. And it's got 90,000 is equal to v1 squared plus v2 squared. So 90,000 is equal to v1 squared plus v2 squared. And if I rearrange this, I can get v2 squared is equal to 90,000 minus v1 squared. Alright, so once I have that, I can substitute this into where v2 squared is in equation 4. So I'll have v1 squared minus 300 square root of 3 v1 plus 90,000 equals 90,000 minus v1 squared. Okay, so let us now cross all these things out. We can cross so many things out. We can minus 900 on both sides. We can plus v1 squared on both sides. So then I have 2v1 squared minus 300 square root of 3 v1 equals 0. We've nearly solved this whole thing. Right, because now I can factorize out the 2v1 times v1 minus 150 square root of 3 is equal to 0, factorizing. And now I have the null factor theorem that says when two terms multiply together to give you 0, then either 2v1 is 0, v1 is 0, or v1 minus 150 square root of 3 equals 0. v1 is equal to 150 square root of 3, which is 259.8 meters per second. So that's awesome. And now I can use that to figure out v2 because I had this equation here. Right, so I can just go 90,000 minus v2 squared, or v2 equals 90,000 minus v1 squared, square root. Alright, and that will give me 150 meters per second. Okay, so that's all very useful, and now the last thing I want is theta, so let's try and solve that. So I have where are my equations? So remember this equation, negative v1 sine theta equals v2 sine theta. So let's copy that one down. Negative v1 sine theta, or sine 30, equals v2 sine theta. Right, that was this equation. Equation 1 originally. Right, this is what I had. So I'm going to now rearrange that. So sine 30 is a half, so negative v1 over 2 equals v2 sine theta. v1 was 150 square root of 3. v2 was 150. So sine theta is equal to negative 150 square root of 3 over 2 divided by 150, and then obviously the 150s will cancel each other out, so it becomes negative square root of 3 over 2 equals sine theta, and then theta will equal inverse sine negative square root of 3 over 2, and you will simply get negative 60 degrees. And there is the answer to our whole question. Alright, theta, which is the angle that the second object is moving at, this angle here is 60 degrees. 60 degrees. The negative means it's below the horizontal, right? If it was 60 degrees positive, that means it'll be going up, but negative means it's going down. So theta is 60 degrees, and we found v1 and we found v2, which is the speed of each molecule. Okay, thanks for watching, guys. See you next time.